Most science teachers would agree that the most important topic when discussing data is unit conversions. This is because it gets used so frequently for the rest of the school year, and also professionals are doing this all the time. People who travel are doing this all the time. We'll show you a foolproof method for unit conversions by teaching you 4 examples where they each get a little bit harder. This is Screencast 2.8. Foolproof method for converting units. Start with what you're given. Write the final units you need to get to. Draw a line or 2 lines or 3 lines depending on how many steps you think it is to convert it, and then go ahead and convert and cancel your units to be sure that everything looks kosher. $7.25 is how many quarters? I bet you can do it in your head. But scope out these hard problems here, and that's why we're going to set this one up anyhow. What are you given? $7.25. Where do you need to get to? Quarters. So that's at the beginning, that's at the end. How many steps? Looks like 1. Nice setup. Now, we know that 4 quarters is $1, but should we write 4 quarters divided by $1 or $1 divided by 4 quarters? Well, dollars has to cancel, so make sure dollars is over itself. Dollars over dollars equals 1. And we multiply and get 29 quarters. Notice that we always cancel our units since units can be worked with mathematically. Dollars over dollars is 1, and that's the unit that spits out, and that's the units that we want. Okay, a little quicker. For this one, there's what you're given, there's where you're going, and in this case you better write $1 is the same as 4 quarters, so that quarters over quarters cancels. And you get 1285 divided by 4, which is $321.25, and that's about what you'd estimate, right? Now here's one that's tough to estimate. 65 miles an hour, that's highway speed. How many meters per second is? I don't know. So we have to just set it up. What are you given? 65 miles an hour. Where are you going? To meters per second. How many steps is it? Well, probably 2, right? Because we're going from miles to meters and hours to seconds. And fortunately, some nice teacher gave us a hour to second direct conversion. Let's first go from miles to meters. A mile is the same as 1609 meters. Notice it would have been incorrect to write it flipped over. That would have been like miles squares divided by meters. But these will just cancel and give us meters. To go from hours to seconds, we put hours on top, and that's the same as 3600 seconds. So 65 times 1609 all divided by 3600 equals 29 meters per second, and the units cancel beautifully. Meters per second is the only thing left standing. Okay, here's a toughie. This is from a unit like 11. Most gases occupy 24 liters per mole at room temperature. It's true. Given that carbon dioxide has a molar mass of 44 grams per mole, what's the density of carbon dioxide at room temperature in grams per liter? This is a real problem. You already can solve this by unit conversion. You might be tempted to say density equals mass over volume, but what's the mass? I don't see any plain old mass units here, and so it seems a little bit scary. Start with what you're given, which is given that blah blah, so it's 44 grams per mole. Looks to me like a one-stepper since we're just going from grams per mole to grams per liter. So we're converting from moles to liters. And 24 liters is a mole, so put moles up here, liters down there, and we should be good to go. 24 liters is the same as a mole. That's a unit conversion. A mole is the same as 24 liters. Notice mole cancels, and we do in fact end up with grams per liter, or in this case, 1.8 grams per liter. This is Screencast 2.8.